Very good morning. Okay. So today we are with YouTube only. So no need to worry. Now we were talking about aldehydes and ketones. Aldehydes and ketones. 1 minute. Okay. So can any one of you tell me what we had discussed in the last class? What we had discussed? Anyone? What we had discussed in the last class? Fast. Okay, 1 minute. Whether board is visible? Okay. So we have discussed about still the people are not sending the word. What is that we have discussed in the last class? We were talking about ammonia reaction with ammonia. Okay, ammonia and its derivatives. Reaction with ammonia and its derivatives. That's what we were discussing about. Right? All of you agree with me? Okay. So in that case, with respect to ammonia, what is that product? Aldehydes and ketones will form. What is that the name of the product with respect to ammonia for aldehydes and ketones? Anyone? Which is that product which will be formed with aldehydes and ketones when reacts with ammonia? Any one of you? Sanjana or Brinda or Purnima, Rakesh, some of the names I am taking. Any one of you can give me the answer for this one? What will happen when aldehydes and ketones reacts with ammonia? Wow. Yenaru helkali sir. We are not giving the answer, that's all. Yeah, that's what I think so. You people have decided not to give any answer. Yes, it's true. Okay. So it will form imines. Okay. So what is that imines? So imines means nothing but where double bond NH group will be there. Where double bond NH group will be there. So that's where we have the reaction with ammonia. So they are going to form the imines. Okay. So next one, reaction with hydroxylamine. Reaction with hydroxylamine. Can any one of you tell me what will be the product with respect to hydroxylamine? So what is that hydroxylamine? One of the hydrogen of ammonia replaced by OH group. So that's where we have the hydroxylamine. Okay. So it's going to form the amines. Yes, Purnima. Very good. So it's going to form the amines. Oh, sorry. It's going to form the oxides. So I'm asking about hydroxylamine. It cannot be amines. It should be oxides with respect to hydroxylamines. They are going to form the oxides. So what is that oxide? NOH. So that's where we have the oxides. So that's where we have the oxides. Okay. So which will be formed when aldehydes or ketones reacts with hydroxylamine. So one of the reaction which people have studied during the structural elucidation of the glucose. Okay. So next one. I think pretty much she was talking about this one. Reaction with the amines. Reaction with the amines. For example, aniline, benzenamine or methylamine. So they are all examples for the amines. So what is that product you are going to expect with respect to amines? What is that product? So what are amines? Are NH2. Are NH2. What is hydroxylamine? So hydroxylamine is nothing but NH2OH. In the name itself it is there. Hydroxyl. Hydroxylamine. NH2. One line, NH2 is nothing but amine. So that's what we can see. Amine. So hydroxylamine, amines. Okay. Now with respect to amines, what will be the product for aldehydes and ketones? Which is that product they are going to form with aldehydes and ketones when it comes to skiff base? Yes, Rahul, very good. So they are going to form skiff base. They are going to form the skiff base. So what do you mean by skiff base? So skiff base is nothing but carbon, nitrogen, double bond will be there. Carbon, nitrogen, double bond will be there. Okay. Now another partner will be R, where R will be not a hydrogen. It should not be an hydrogen. Then it is called as skiff linkage. And those molecules which are having skiff base will be considered as skiff linkage will be considered as skiff bases. Okay. So yes, Purnima. Next one will be with respect to hydrazine. Next one will be with respect to hydrazine. When I am talking about hydrazine, so what is that hydrazine? NH2, NH2. That is nothing but hydrazine. Now, which is that product which will be formed with respect to hydrazine? It will be hydrazone derivatives. So it will be hydrazone derivatives. Okay, that's where we have the NH2. That's where we have the hydrazone derivatives. So hydrazone derivatives will be formed when aldehydes or ketones reacts with the hydrazine. Okay. So now next one is with respect to similar molecules. That means hydrazine derivatives only. So which is that molecule? That is phenylhydrazine. That is nothing but phenylhydrazine. Reaction with phenylhydrazine. Okay. Now, what is that hydrogen? NH2, NH2. So, phenyl hydrogen is nothing but where we will be having the benzene ring, NH, NH2. So, this is nothing but phenyl hydrogen. Okay, that is nothing but phenyl hydrogen. So, what will be the product? Yes, Jannavi, it is hydrazone in earlier case. Here, with respect to phenyl hydrogen, what will be the product? Any one of you? Yes, hydrazone, when it reacts with hydrogen, what will happen when phenyl hydrogen is going to react? What will be that product? So it's going to form phenylhydrazone. It's going to form the phenylhydrazone derivatives. Phenylhydrazone derivatives. Phenylhydrazone derivatives. So any examples I took? Application of phenylhydrazine in detecting some of the compound. Any examples we have discussed in the last class? Any one of you? Any examples we have discussed with respect to this one? With phenylhydrazine? Any one of you? Yes. Very good. But Jahnavi, it is not ozone. It is oxidation crystals. That is nothing but oxidation crystals. So where it will be used? For the detection of carbohydrates. For the detection of carbohydrates. Whether a given sugar is a lactose, or whether a given sugar is a maltose, or whether a given sugar is glucose or fructose. So this distinguishing of these sugars can be done, or identifying these sugars can be performed by using shape of these oxidation crystals. Okay, so these oxidation crystals are nothing but phenylhydrazone derivatives of these sugars, which will give different shapes, which will form different shapes of the sugars. Okay. So got my point? So that's where we have the phenylhydrazine. Then we have derivatives of phenylhydrazine, that is 2,4-dinitrophenylhydrazine, 2,4-DNP. Okay? So 2,4-DNP, or sometimes 2,4-DNPH. That also they will use. Anything is fine. Okay? So 2,4-dinitrophenylhydrazine, that is 2,4-DNP or 2,4-DNPH. But don't use the short form in your exam, please. Yes, Purnima, 2,4-dinitrophenylhydrazine. Very good. So in the name itself it is there. It is nothing but hydrogen only. So it is nothing but hydrogen only. At second and fourth carbon, there will be a nitro group. At second and fourth carbon, there will be a nitro group. Therefore, it is called as 2,4-dinitrophenylhydrazine. Now, what will be the product? So, once again, 2,4-dinitrophenylhydrazone derivatives. Phenylhydrazone derivatives, right? So where this will be applicable? For what purpose DNPH reagent will be utilized normally in a laboratory? Anything we have discussed? 2,4-dinitrophenylhydrazine. So where it will be utilized? Hmm? Where it will be utilized, and it's also called as Bosch reagent, right? So Bosch reagents or Brady's test, Brady's reagent. So where it is applicable? For the quantification, for the quantification of the glucose. It will be utilized for the quantification. Quantification means what? Quantification means finding the exact amount of glucose. So for finding the quantification of, glucose, DNPH will be utilized, and it's called as DNPH test or Brady's test. Got my point? So that's where we have the application of DNPH. So that's where we have the application of DNPH, 2,4-dinitrophenylhydrazine. And the last one, can anyone of you tell me which is that last one we have discussed? We have discussed about semicarbazide. Okay. So what is semicarbazide? Semicarbazide is nothing but NH2, NHCO, NH2, where urea is going to replace the one of the hydrogen of the hydrazine. Yes, Jannavi, that is semicarbazide. So what will be that product? So that will be semicarbazole. They are going to form semicarbazole. Okay, so that's where we have the reactions. So that's where semicarbazide is going to react with aldehydes and ketones to form the semicarbazone derivatives. It's going to form the semicarbazone derivatives. Fine. So that's what we have discussed in the last class with respect to reaction with ammonia and its derivatives. So in that you should remember about the oxides, then you should remember about the hydrazone derivatives. Okay, all these things try to remember. Skiff base. Fine. Now whatever I will be discussing now, these things you people have already studied in your first PU. You people have already studied, second PU in alcohol, phenols and ethers topic. So this particular thing you people have already studied in your alcohols, phenols and ethers topic. So that's where conversion of aldehydes and ketones to alcohol, to respective alcohol. So these things you people have already studied in your alcohol, phenols and ethers topic. You people have already studied in your alcohols, phenols and ethers topic. So now, can anyone of you tell me what we should do to convert aldehydes and ketones to their respective alcohol? Just tell me the process name or the name of the reaction. What we have to do? Name of the reaction in the sense it's not related to some person's name. I am talking about what is that process. So whether it is elimination or addition or oxidation or reduction, that's what I mean to tell. So which is that one which we should carry out for the conversion of aldehydes or ketones to their respective alcohols? And these things already we have studied in your alcohols topic. Which is that process we should carry out? First, Can you tell me the name of the process? What we have to do for conversion of aldehydes and ketones to their respective alcohol? That mixing was on, na? That's right. Fast. How to convert aldehydes and ketones to alcohol? It's a repetition actually. In alcohol's topic it is done. Or I will write the molecules. So that is O. This is aldehydes or ketones. Aldehydes or ketones, and they will be converted into R. Okay, so OH. So that's where OH. Okay, so if I consider it as an aldehyde R CHO, then it will be converted into R CH2OH. If I consider this one as a ketone, then it will be converted into R CHOH. So that's where we have the primary alcohol, right? And that's where we have the secondary alcohol. So that means aldehydes always it's going to form the primary alcohols. Okay, addition of hydrogen. Even Krishna was telling the same thing, addition of hydrogen. Yes, very good. So that we can call it as hydrogenation. We can call it as hydrogenation or any other name.
Reduction.
Yes, it should be a reduction. Very good. It should be a reduction. Hydrogenation, and another broad term can be reduction. Hydrogenation is very specific because where we are talking about reduction of a given molecule by adding the hydrogen, we are specifying. Reduction is a broad term. So therefore, this particular reaction can be considered as a reduction by hydrogenation process. Okay? So that's where we have aldehydes which will be giving rise to primary alcohol, and that's where we have the ketones which will give rise to secondary alcohol. Okay? Now, which can be the reagents?
Strong reducing.
Okay. So Krishna is telling strong reducing agent.
Ketone.
So which is that strong reducing agent?
And
In first PU and even alcohol's topic we have studied. So which is that strong reducing agent? Anyone? So that is lithium aluminium hydride. That is nothing but lithium aluminium hydride, LiAlH4. Okay, so that's what lithium aluminium hydride. Okay, so what is hydride? Where hydrogen will be with -1 oxidation state. They are called as hydride. Okay, so this is proton. So hydride -1 oxidation state. So aluminium which is attached to 4 hydrogen. Okay, so naturally it will be having a net -1 charge because aluminium can have +3, but we have 4 hydride ions. So to neutralize that one we have the lithium. So that's why we have the lithium aluminium hydride. Okay, so now that's where one of the strong reducing agent. Lithium aluminium hydride is a strong reducing agent. It's a strong reducing agent. So what we should remember here is, for ketones to get converted into respective alcohol, that is a secondary alcohol, we require a strong reducing agent, that is lithium aluminium hydride. Now what about aldehydes? Whether we cannot use lithium aluminium hydride? We can use, nothing will happen. We can use the lithium aluminium hydride, but it is not required. Such a strong reducing agent is not required. We can save the cost. So therefore we can go with a mild reducing agent, which is that which is that mild reducing agent. Lithium aluminium hydride is a strong reducing agent. So which is that which can be used for as a mild reducing agent, which is more than enough for the conversion of aldehydes to primary alcohol. Can any one of you tell me? So which we have studied in S block elements in first PU. So that is sodium borohydride, one of the best example. Like lithium aluminium hydride only, we have sodium borohydride. Okay. So now boron belongs to same group, that is aluminium. So group 13, boron and aluminium. So naturally we have the boron, which is attached with the 4 hydride. So which will have the -1 net charge, which will be neutralized by the sodium +1. So that's why we have the sodium borohydride. But still, this will be acting as a mild reducing agent. It will be acting as a mild reducing agent. Although central metal, aluminium, group 13 element, so boron, group 13 element. Then lithium, group 1 element, sodium, group 1 element. Although the elements which are involved, they belongs to same family, but still one is acting as a strong reducing agent and another one is acting as a mild reducing agent. What can be the reason? Any one of you? How it's possible? Both are hydrides containing molecules, but still in one case it is a strong reducing agent, in another case it is a weak or mild reducing agent. What can be the reason?
Difference in the cations resulting in Fazan's rule. So here hydrogen will be less ready to give it up.
Okay, very good answer. So simply we can call it as strong bonding present between boron and hydrogen and a weaker bond present between aluminium and hydrogen. So that will be the answer. Okay. So due to this weaker bond, lithium aluminium hydride will act as a strong reducing agent. They can easily donate the hydrides. But when it comes to boron and hydrogen, since the linkage is bit strong, so therefore it will be weak donor or it's a poor donor of hydride ions. Okay. So therefore one is acting as a mild reducing agent and another one is acting as a strong reducing agent. So what we should keep it in our mind? We should keep in our mind that aldehydes will give rise to primary alcohol and ketones will give rise to a secondary alcohol. It is reverse. It is exactly reverse with respect to preparation of aldehydes and ketones from respective alcohol. It is exactly the reverse condition. So where secondary alcohol will give rise to ketones and a primary alcohol will give rise to aldehydes. But there it was an oxidation process and here it's a reduction process. All of you got my point? Any doubts with regard to this one? Okay, so try to remember these reagents. Now whatever I will be discussing or telling now, it will be considered as very important for the examination point of view. Okay, and one is Clemenson's. One is Clemenson's. So Clemenson's reduction. One is Clemenson's reduction. So earlier whatever we have discussed, that is also Clemenson's that is also reduction only. That is conversion of aldehydes and ketones to respective alcohol. And here also we are talking about the Clemenson's reduction. That is reduction process only. Now what is that difference? So in this case, aldehydes or ketones, aldehydes or ketones will be converted into respective hydrocarbons. Respective hydrocarbons. That's where Clemenson's reduction differs from the earlier case. In earlier case, what was happening? Although it was a reduction process, it was a hydrogenation reaction, where aldehydes and ketones, they were added with hydrogen and they were converted into alcohols. Here, it is also a reduction process only. That's why the name is given as Clemenson's reduction. But here, it's not simply an hydrogenation. Okay? Because we are talking about conversion of aldehydes or ketones. So that means, if I consider this one as aldehydes or ketones, it is getting converted into hydrocarbons. It's getting converted into hydrocarbons. For example, CH3, CO, CH3. So which is this molecule? It is a acetone. A common name is called as acetone, or we can simply call it as propanone. We can call it as propanone. By the Clemenson's reduction process, it will be converted into anyone? Krishna has given the answer already. It will be converted into, that's what I have written, bond line formula, and here I have written the molecule. So which is that molecule in the product side? So propanone getting converted into, any one of you? It is getting converted into N-propane. It's getting converted into N-propane. So that's where, what is happening in the reaction? No doubt it is a reduction process, because this carbon is added with the hydrogen. But whether it is simply an hydrogenation process? No. At the same time, there is a removal of oxygen also. There is a removal of oxygen also. So therefore, in Clemenson's reduction, there will be addition of hydrogen, okay, and there will be removal of oxygen. Carbonyl oxygen will be removed. So in both the circumstances, it is a reduction process. Therefore, it is called as Clemenson's reduction. That's why it is called as Clemenson's reduction. Hagadre, this will be carried out in the presence of zinc amalgam. What do you mean by amalgam? It is a alloy. It's a alloy where zinc metal is mixed with mercury, which is also a metal. So that's why we have the zinc amalgam. Okay, amalgam is nothing but a mixture or a blend. Amalgam is nothing but a mixture. Okay, so mercury is a metal, liquid metal, and it will be mixed with another metal. So therefore, zinc amalgam can be an example for alloy. ಅದೇ ರೀತಿ we have silver mercury combination which will be used for earlier they used to use for filling into the teeth and all. Okay, so that's why we have the zinc amalgam. Now another reagent which will be required here will be HCl. Why HCl will be required? HCl is helpful in protonation of carbonyl oxygen, which can be later removed easily in the form of water. So what is the role of HCl? HCl helps in the protonation of oxygen, protonation of carbonyl oxygen, that will be more appropriate word, carbonyl oxygen, and later can be removed, not HCl, I am talking about oxygen, can be removed in the form of water, in the form of water. That's where HCl is very much required for the reaction. Okay, so what about zinc amalgam? What about zinc amalgam? What is the oxidation state of the zinc in zinc amalgam? It should be 0. As I told, it's an alloy, so it should be 0. Where zinc is going to help in the hydrogenation process. Where zinc is going to help in the hydrogenation process. Yes, Ravikant, it will be a 0. Okay, absolutely correct. So that's where zinc amalgam, zinc is helping in the addition of hydrogen to the carbonyl carbon, and HCl helps in the removal of the oxygen. So that's where we have the Clemenson's reduction process. In that case, what should be another product? Anyway, that is not required to answer, means to write it in the exams. If you write, no problem. But if you don't write, then also no problem. But which is that another product you expect? Krishna has already given the answer. Which is that another product you expect? In the exam, you can write that product, or you may not write that product. You will get the marks, because important one is you should talk about aldehydes or ketones, and you should talk about respective hydrocarbons. Yes, Shrestha, very good. That should be water. That should be water. Another product will be water. Fine? All of you have understood? So in that case, in Clemenson's reduction, if I take a molecule CH3, CH2, COH, what is that product you are going to expect? First thing, what is that I have written on the board? IUPAC name. Same molecule I have written like this. Which is this molecule? Whichever I have written on the board, which is this molecule? IUPAC name. Krishna has already given the answer. Any one of you? What is the IUPAC name of this molecule? So that is nothing but propanol. Okay? So that is nothing but propanol. Right? Same thing. I can write like this also. CH3, CH2, CHO. Both the ways it is correct only. Both the ways it is correct only. So Ravikant, I think in a hurry you have written, it's not propanol, it is propanol, AL, last one. So propanol, okay? So naturally, when propanol is going for Clemenson's reduction process, propanol is going for Clemenson's reduction process, what will be the product? It will be propane, N-propane, CH3, CH2, CH3. So we are going to get the N-propane as the product. So what I mean to tell you is, whether I take propanol or propanone, in both the cases with Clemenson's reduction process, they will convert it into same hydrocarbon, that is N-propane. Okay, this is very important for your examination point of view. Clemenson's reduction process or Clemenson's reduction reaction. So, ಹಾಗಾದರೆ what is that important point here is, in Clemenson's reduction reaction, aldehydes and ketones, they will get converted into respective hydrocarbons. They will convert it into respective hydrocarbons. Now, important point here is, if aldehydes and ketones, if they are having same number of carbon, then naturally they will give the same hydrocarbons. That's what we have seen. Propanol, propanone, both will give the propane only. Okay? So that is because there is no loss of any carbon. So that's why we have the Clemenson's reduction process. So next one is Wolff-Kishner reduction. Once again, very, very important. So next one is Wolff-Kishner reduction. Wolff-Kishner reduction. Okay. So another important reaction. So once again, it is similar to that of the Clemenson's reduction. So here also aldehydes or ketones, they will get converted into respective hydrocarbons. They will get converted into respective hydrocarbons, aldehydes or ketones, whichever you take. If you provide the suitable condition, they will get converted into respective hydrocarbons. So naturally, with respect to the reactant and with respect to the product, both looks same. But other reagents will be different. And one of the reagent which we are going to discuss, already we have discussed in yesterday's class. So that is, one of the reagent used in this particular process is hydrazine. One of the reagent which will be used in this particular process is hydrazine. What is that hydrazine? NH2. That is nothing but hydrazine. Now, if I take aldehydes or ketones, when they reacted with hydrazine, what will happen? Any one of you? What will be happening? Just now we have discussed in the beginning of this class, while revising whatever we have discussed in the last class. So hydrazine treated with aldehydes or ketones, what will happen? What is that product which will be formed? What is that product we expect? Okay. Acetaldehyde hydrazone. Oh, Ravikant, that much is not required. I have not mentioned here. It is R. Okay. So you can simply call it as hydrazone. Ravikant. Okay. Purnima. Yes, it should be hydrazone. So that's where we have the removal of water. So H2O. There is a removal of water straight away. Okay. Now double bond NH2. This is hydrazone derivative. Simply call it as hydrazone derivative. Okay, Ravikant? So you can call it as hydrazone derivatives. Okay, na? So that's where we have one of the reaction. Yes, Brinda. Hydrazone will be formed. Now it will not stop here. Because we have to further get the product. Which is that product? Hydrocarbons only. So we have to get hydrocarbons or CH2R. Fine. Respective hydrocarbons will be formed. For that ones to happen, what we have to do? For that ones to happen, whatever H2 is there, it should come here, and these two nitrogen has to be removed. These two nitrogen has to be removed, right? So then only we are going to get the hydrocarbons. If these two nitrogen will comes together, which is that product? That will be nitrogen gas. That will be a nitrogen gas which will be formed. Okay? Now, this particular reaction can take place at high temperature. You can simply mention it as heat at high temperature, and in the presence of KOH or ethylene glycol. KOH or ethylene glycol. So what that KOH or ethylene glycol will do? They helps in the liberation of nitrogen by deprotonation of this particular nitrogen. Listen to me carefully. What is the role of potassium hydroxide or ethylene glycol? So they helps in the deprotonation of this particular nitrogen. So due to that, nitrogen can be liberated. Where nitrogen can be liberated. So that is the role of potassium hydroxide or ethylene glycol. So potassium hydroxide helps in the liberation of nitrogen. Helps in the liberation of nitrogen. Okay? So if you don't use potassium hydroxide, naturally reaction will not be feasible. Okay? Because hydrazone is a quite stable product. So to convert that hydrazone into hydrocarbons, we have to provide the condition. And also we have to provide the high temperature also. Got my point? So that's where we have the Wolff-Kishner reduction reaction. So what is that difference between Clemmensen's reduction and Wolff-Kishner reduction? In Clemmensen's reduction we are going to use zinc amalgam and HCl, acidic condition. But in Wolff-Kishner reduction reaction, we are going to use hydrazine, potassium hydroxide and high temperature. That means when it comes to the reaction environment or reaction condition, Clemmensen's reduction will be under acidic condition and Wolff-Kishner reduction will be under basic conditions. Okay? All of you have understood? So that's...
Why can't we just provide a strong reducing agent and then we'll get back hydrazine?
Okay, what do you mean?
From hydrazine derivative.
No. This double bond is not. We cannot take back the hydrogen. We cannot take back the hydrogen. Hydrogen will be taken back when we provide the hydrolysis. Then what is the use? We have to go for further, right? So therefore, otherwise, once again it will be reformed. So Krishna's question is, why can't we take back hydrogen by using strong reducing agent? That's not possible. Okay? So only by adding of the water opposite to this one. Add the water, we will get the hydrogen and respective aldehydes or ketones. It's of no use. Because we want to convert aldehydes and ketones to hydrocarbons. That's where we have the important reaction. That is Wolff-Kishner reaction. Now, in both the cases, there will be formation of the hydrocarbons. That means if we are taking, product will be same in both the cases. What I mean to tell you is, if I take propanone, whether I am going with Clemmensen's reduction or Wolff-Kishner, in both the cases there will be formation of N-propane. But how to identify whether it is Clemmensen's reduction or Wolff-Kishner's reaction which is taking place, because we don't know which reagent has been added. But still by observing the test tube, we can find out which particular process has been carried out. You got my point. What Raghavendra sir has done is, sir has taken the test tube, he has put aldehydes or ketones, then he has put reagent in absence of few people, then he showed you the tube telling that this is the reduction process where I am getting the propane as the product. But on what basis you are telling that whether Raghavendra sir has followed Wolff-Kishner process or Clemenson's process?
No fire test. Nitrogen will.
Okay. So one of the easy ways, if there is a bubbles, because nitrogen gas will be released if you are following Wolff-Kishner's process. So if there is a bubble, that indicates that Raghavendra sir has followed Wolff-Kishner's process. Because in case of the Clemenson's reduction, there is no formation of any gaseous product. Got my point? That is the one thing, that's the difference. In case of the Wolff-Kishner process, there will be a liberation of nitrogen gas. Okay? Any doubts with regard to this one? Shall I move to the next one then?
Is nitrogen gas flammable?
Oh no, nitrogen gas no. It's very stable, triple bond is there.
So it is like if we put a matchstick near the test tube, not that should.
That is hydrogen, not nitrogen. Nitrogen gas is not flammable. Okay?
So it will like off the matchstick.
Nothing will happen until unless you stop the oxygen supply. Then naturally it will put off. Okay? So shall I move to the next one then? So whatever we have discussed, it is nothing but reduction. Reduction of aldehydes and ketones to alcohols, or reduction of aldehydes and ketones to respective hydrocarbons. Now we are going to discuss about the oxidation. Give me another 2-3 minutes. Now we are going to discuss about the oxidation. Hagadre, I have aldehyde, or I have a ketone. If I oxidize these two, what product you are going to expect? What is that product you are going to expect?
Carboxylic acid ester.
Okay. So Krishna is telling either carboxylic acid and esters. Whether he is right? When aldehydes and ketones, when they are oxidized, what will happen? Naturally, we are going with a strong oxidizing agent with respect to the ketones and a mild oxidizing agent with respect to aldehydes. What is that product? So, in this case, it will be a mild oxidizing agent. See, in reduction also a mild condition. In oxidation also mild condition for aldehydes. But when it comes to ketones, it will be a strong oxidizing agent, or we have to provide bit harsh conditions like high temperature and all. When it comes to ketones, naturally they will give rise to respective carboxylic acid, no esters, respective carboxylic acid. Even ketones will give the carboxylic acid, which will be 2 in numbers. Observe it carefully. I will make it as R prime. Then one will be one carboxylic acid and another one will be another carboxylic acid. How it's possible? By the cleavage of the linkage. By the cleavage of the bond. So what I mean to tell here is, with respect to the oxidation, for the conversion of aldehydes and ketones to their respective carboxylic acid, aldehydes there is no cleavage of any bond between carbon and carbon. But in case of the ketones, there will be cleavage of the bond present between the carbons. Got my point? So that's where aldehydes and ketones, they differ from each other with respect to oxidation. Fine. So anyway, in detail about these reactions, we are going to discuss in tomorrow's class. But any doubts? Another doubts, Vidya? If you have any doubts, you can ask. So otherwise, tomorrow we will continue. So two reactions which we have discussed, it is very important. One is Clemenson's reduction and another one is Wolff-Kishner's reaction. They are all very important, both of them. Okay? So if you don't have any doubt, shall I disconnect then? Thank you. Thank you very much. Take care. Bye.